ORC layout, adaptive GUI layout with all constraints. We propose a novel approach for constraint-based graphical user interface layouts by adding all constraints to standard soft or hard linear constraint systems. ORC layouts is a new powerful way to express GUI layouts, seamlessly integrating all constraints into standard constraint systems for layout specifications, and can be solved at interactive rates. Various layout patterns are supported. One of the biggest benefits is that all constraints can unify flow layouts and grid layouts, which opens up options for layouts that work across screen rotations and the cases where grid and flow layouts individually fail. Our ORC editor supports all standard interactive edit operations, such as inserting, resizing, moving, and deleting widgets, as well as resizing the canvas. We allow end users to resize the canvas. For efficiency, we resolve only when the user finishes a drag operation. Widgets can be moved and resized via drag and drop. Widgets can also be deleted by being dragged and dropped outside the canvas. ORC layout covers a superset of the most popular layout mechanisms, allowing designers to blend them. To achieve this in a controlled manner, we propose patterns as basic building blocks that can be combined into layouts of arbitrary complexity. Our system can switch between the horizontal float layout pattern and the vertical flow layout pattern. The horizontal flow layout pattern uses an OR constraint to the right or at the start of the next row. The vertical flow layout pattern has an OR constraint to the bottom or at the start of the next column. In the cross-cutting layout pattern, the top toolbar is a horizontal flow pattern, and the left toolbar is a vertical one. The toolbars automatically transform into multiple rows or columns as the screen gets smaller. The connected layout pattern is a generalization of different layouts, such as horizontal and vertical flow, which emerges by connecting the sub-layouts of GUI so that widgets can move between them. In the balanced flow layout pattern, when the widgets in the toolbar are broken into rows, each row can only have a predefined number of widgets, which is a factor of the number of widgets in the toolbar. In the alternative position layout pattern, with a simple OR constraint, we can define alternative positions for widgets on entire sublayouts. For example, a top toolbar can be changed to be a left toolbar or vice versa. When a window is made smaller, some widgets can be made optional. Moreover, if a window does not have enough space, some widgets can have alternative representations to save space. For instance, list boxes can be replaced by optional menus. In conclusion, our ORC layout is a novel GUI layout method that adds all constraints to standard constraint-based layout specifications. Through the use of efficient SMT solver, ORC layout constraint systems with soft, hard, and all constraints can typically be solved at interactive rates. We envision that our new layout method could be widely applied in modern web design, document format, and app layout. Thank you.